Math 95, I'm going to go through the rest of the Chapter 7 notes. And the completed notes to this are up on Lumen, and somehow when I scanned it, this was a semester or two ago, I scanned them, the pages kind of got out of order. So they are all there, and a couple of them are doubled for some reason. But just look at the bottom of the page at what page number you're on, and it'll match up with your notes. So everything's there still. All right, so we're going to start on page 7, if I can find my page 7. And we're talking about radicals. A radical is another name for a root. So you might think about a square root, okay? And overall, those are called radicals. So we have on your page there, we have radical or square root of 16. So this is an example of a square root. So I always think of roots as a question, okay? So I think of this is what you can put on your paper there, in the line. It says radical 16 means, and I always think of it, excuse me, as this question. What number multiplied by itself, trying to see how I had it worded on their paper there, equals 16. Okay? What number that's the question it's asking. What number multiplied by itself equals 16? If we want to kind of draw it out, we can say, okay, this times itself is going to be 16. Well, hopefully all those multiplication facts are in your head, and you think, okay, well, it's 4 times itself. There are other ways to make 16, like 2 times 8, but that's not a number times itself, right? So that means that when I'm asking this question, what's the square root of 16, the answer to that is going to be 4. Okay. Notice my answer does not have a square root anymore. I've answered that question of what multiplied by itself, so it's just a plain old number. Okay, next one. Looks very similar to a square root, has this little 3 in the crook of the root sign. Okay. This is called a cube root. When we're talking about exponents, if something is to the second power, it's squared. If it's to the third power, it's cubed. This is kind of going the other way. It's a cube root. So again, I think of this as a question. This means what number multiplied by itself 3 times equals 8. How do I know it should be multiplied by itself 3 times? Well, because of this little number here. This is called the index. So if this were 5, my question would be, what number multiplied by itself 5 times equals 8? Or 8 times, or whatever this index is, that's how many times this number is being multiplied by itself to get the number under the root. Now square root, I mean really if you think about it, it's kind of like having a 2 there, because I multiplied this twice. But the 2 is just kind of implied in a square root. So if we think about this, I'm not saying what times 3 equals 8. I'm saying what times itself 3 times. So with cube roots, you might not know them, but we can figure them out on your calculator, which I'll talk about in a second, or we can just think, okay, what is 1 times 1 times 1? That's 1. 1 times 1 is 1. 1 times 1 is 1. How about 2's? 2 is not 2 times 3. It's 2 times 2 is 4. 4 times 2 is 8. Okay? So in this case, this is what would multiply to be 8. So what's my answer? The cube root of 8 is just going to be 2. Okay, so on your calculator, depending on what kind of calculator you have, you may have a button that is for cube root. You can do that button and then 8. More likely you have something like this, where it's like x and then either just a square root or has y in there, something like this. If you have that, then whatever you put into the calculator before this button is going to be your index. So you put in 3, then this button, and then 8. Whatever you put in after that button is going to be your number in the root. Okay? If you have questions about your specific calculator, you can always email me. You can also, if you Google like the model number, often it comes up with some kind of manual or help also. Okay. So now we want to think about these numbers for a minute. So I have the square root of 16, right? And I got this nice number 4. Kind of a neat answer, right? Simple, pretty, nice, not too scary. So what would happen instead if I took the square root of 15? On your calculator, if you have it handy, go ahead and take the square root of 15. And you will find that you are going to get a decimal, 3 point something, and it's going to go on and on and on. Okay, it actually goes on forever. It's called an irrational number. We talked about that at the beginning of the semester. So an irrational number goes on and on forever without ever repeating or ending. So how come sometimes I get a decimal that goes on forever, an irrational number, and sometimes I get a nice integer? Well, that's because some numbers have an integer where 4 times 4 equals 16, right? There's no such number for 15. I mean, 3 times 3 is 9, or 3 squared is 9. 4 squared is 16. Everything in between here is going to be 3 point something. So these are special numbers because their square root is an integer. So we call those perfect squares. So if you see on your paper, there are 3 lines there. It says, what are some, and I'm just going to only write that once, so I don't have to keep writing it, perfect squares, perfect cubes, and perfect fourths. So what does that mean? Well, perfect square means, I'll put it over here. Its square root is an integer. What's a perfect cube? Its cube root is an integer. A perfect fourth means its fourth root is an integer. We'll get to that in a second. So, how do I get these? Well, on your yellow sheet that you had in class, there's a list of perfect squares and perfect cubes also, but we can also just come up with this list on our own. If a number is a perfect square, like one of these, it means its square root is an integer. So we can do it the other way. We can say, well, what is 3 squared, right? What is 4 squared? So 1 squared, 1 times 1 is going to be 1, 2 times 2 is 4, 3 times 3 is 9. So these are all perfect squares because I'm getting them by squaring an integer. I'm not saying what's 3.776 times 3.776, right? I'm just using all integers. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36, etc. Okay, I'm going to go up. So here's 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. Is that the end of the perfect squares? No, right? There are an infinite number of them. I could take 836 million and square it, and whatever huge number I get would be a perfect square. They go on forever. Perfect cubes, same idea. This means their cube root is an integer. So again, okay, if something times itself is this number that's a perfect cube, well, I can go backwards by saying, okay, what is 1 times 1 times 1? 2 times 2 times 2. Those will all be perfect cubes. So 1, no matter how many times you multiply it, it's going to be 1. 2 times 2 times 2 we saw is 8. 3 times 3 is 9, times 3 is 27. 4 times 4 is 16, times 4 is 64. 5 times 5 is 25, times another 5 is 125. Okay, so I have these written down. I'm just going to do a couple more. So 6 cubed would be 216, 7 cubed is 343. Again, they keep going. Notice they get big fast, and they get big faster and faster as you have a higher exponent. Okay? This is, you have probably heard about exponential growth, things getting faster and faster with the coronavirus. This is the same idea, okay? This is kind of like one person infects so many people and then they each infect so many other people. It gets big very fast. That's the same idea behind this. Okay, perfect fourths. By now you probably understand what this is, right? This is saying that a fourth root of something, like 16 for example, some number multiplied by itself 4 times is going to equal this. So instead of trying to just guess numbers that will work, let's build them by having the same number multiplied by itself 4 times. So 1 times 1 times 1 times 1 is still 1. 2 to the 4th is going to be 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. 81 is 3. 4 to the 4th power is 256. 5 to the 4th power is 625. Again, they're getting big even faster now. Okay, so a couple other little rules we have to look at for radicals, and then we're just going to spend a lot of the time simplifying and doing some examples. Okay, so there's a product property of radicals. Basically all this says is, if you have 2 radicals that have the same index, that's why they both have an n, and they're being multiplied, I can multiply those under the radical. It goes the other way also. So if I have square root of 3 times the square root of 6, okay, first of all, if they're right next to each other like this, that means they're being multiplied. These are both square roots. They don't have a 2 here because it's implied, but they're both the same root. It's not that this is a second root and this is a 5th root. I can put them together and I can say, well, that's going to be square root of 18. Okay, and that doesn't seem to make any difference right now, but it will in a minute. We can go the other way too. So if I have the square root of 20, I can break that up into square root of 4 and the square root of 5. Okay, again, they'll make a big difference in a couple minutes. Okay, other property is the quotient property. So quotient means divide, fraction. So same idea here. If I have same root and it's a fraction, I can put them together. And vice versa. Okay, so this way, my example, let's say I have the cube root of 10 over the cube root of 5. That could be the cube root of 2, right? 10 over. Okay, so we could do the other way also, but generally you don't see it going the other way. All right. Okay, so the last thing on that first page that we need to know, we've talked about perfect squares, perfect cubes with numbers. We need to talk about them with variables. Okay, so a variable with an exponent, let's say x to the 12th. I'm taking the cube root of x to the 12th, okay? X to the 12th is a perfect third. A perfect cube. If the exponent, so this is right in your notes, if the exponent is divisible by the index and comes out to an integer. Okay? So my exponent, in this case 12, can I divide that by 3? Yeah. If I can divide this, then it's a perfect root. I can pull it out and that's my answer. Okay, so think again about what this is saying, or asking. This is asking what number, or in this case, what expression, multiplied by itself 3 times equals x to the 12th. Well, if I try that, if I multiply that by itself 3 times, remember with my product rule, I add these exponents and I'm going to get x to the 12th. Okay? Or I also could have written it like this, x to the 4th to the 3rd. Now I multiply these either way. That's how it works. Okay, so I'm going to stop this video. It's getting a little bit too long, and I'm going to start another one. And we'll be on page 8, and we'll be doing those simplifications, okay?